In general, when I do examples, I avoid using e to a power, just because since the derivative and antiderivative of e to the x are e to the x, it's hard to know when I integrated and when I didn't. So I'm going to try to work some of those in to this review. So how would I do this integral? Is this u sub or integration by parts?
Integration by parts.
False.
The t squared.
U equals t squared. We have an inside, we have nested functions. So if we let u equal t squared, then du is just equal to 2t dt. So du over 2t is equal to dt. So that means that this guy is equal to the integral of t times e to the u, and that dt becomes du over 2t. And now the t's will cancel out. We'll die a cruel and horrible death, as it were. And this will simplify like so. And then, like I said, the derivative and antiderivative in this case of e to the x is just e to the x. So the integral of e to the u is e to the u. Don't forget your plus c. And then, again, replace u with what it equals, because all the variables that you end up with should be the variables that you started with. You don't want to make up new variables, unless you, like, run out of space or something. I'll accept auxiliary variables if, like, the alternative is pulling out some notebook paper to make everything fit. Is that okay? Is everybody good there? All right, so somebody summarize for me, how do I know that this is a u sub problem rather than an integration by parts problem?
Because there's an inside function.
Right, because there's an inside function. Now, sometimes you'll have to do both, integration by parts and u substitution. But if there is an inside function, you're gonna have to do u sub.